Hi, my name is Karel and I'm one of the co-founders of Raymond. In this video, I will give you a short presentation of how our platform works and what you can do with it. So, first of all, Raymond is an observability platform for AI systems. Raymond offers data and model monitoring, troubleshooting and alerting, and continuous improvement support. Using Raymond, you can detect system failures faster, troubleshoot them more easily, and improve your system more effectively. Now, this demo is built around the use case of a house browsing predictor. So imagine that you have a house browsing deployment that looks roughly like this. So you have a deployment class with some entry method that receives some data on which you do a prediction. So first you may do some pre-processing, various transforms of your data, followed by a model prediction and the return of that predicted value. So how would you use Raymond for this deployment? The first thing you should probably do is create what we call a model profile. Now, a model profile is basically a collection of components, and each of those components captures and tracks one characteristic or one feature of your data. Now, these components, they can be from the input of your model, they can be from the output of your model, they can even be of actuals of your model if you have them coming in, and they can be a combination of this output and actual components. For example, an absolute error, which we call an evaluation component. Now, when building this profile, each of these components will track the characteristics of the feature that it extracts. So after building, you will have for every feature, so for example, this is the first floor square footage, and we track the minimum value, the maximum value seen during training. We track the amount or the percentage of invalid values in your data set, and we track the model distribution and a few more things. Now, another thing you could do or could define in your model profiles are so-called reducers, and reducers basically reduce all the values that you see either during training or in production during a certain time window into one or a few values. So in this case, we take this absolute error that we've calculated and reduce it. So we take the mean and we get a mean average error, of course, and we prefer it to be low. So after defining your model profile like this, you build it by simply passing it some data like you would train a model, and you save it. After saving this, you can load this model profile in production and use it to simply validate your incoming data with a one-liner. So here in this line, we basically take the data that we received and we call the profile and do validate input. Now this will generate what we call tags, and based on these tags you can throw errors or whatever you want if you don't want to use the rest of our platform. Likewise, we could also use the profile to validate our model outputs, which will indicate when our model starts going wild, and here too this outputs tags. Now, another thing you could use Raymond for is to increase the debuggability of your system by using traces. And traces are basically, a trace object is a wrapper around an ID, which also functions as an augmented logger. So in this case, every time you receive a prediction request, you create a trace object with some given ID if you have one, or one will be auto-generated. And then using this trace, you can add metadata and raw data and info messages to this trace, which will help you with debugging later. So in this case, we add some metadata, and metadata in this case could be the client that the data comes from, the SDK version that generated the data, the deployment version that processed the data, the model version that processed the data. So basically whatever metadata you want. Next, well, just like before, we validate the input, but now we attach the tags that gets returned. We attach it to the trace too. Further on, we could, for example, log the pre-processed input if you think this is of any value, and the model prediction. And just as before, again, we validate the output and attach these tags to the trace too. Something you could do too is when an error occurs, you could add an error tag to this trace, which will allow you to find it back later easily. So once you've done that, we can go to the web UI. So after constructing the model profile, what you need to do is to upload it to the Raymond backend, and then the Raymond backend will basically auto-configure and generate issues and alerts for you if you want to. So in this case, I've generated some sample data, and the sample data comes from 3 possible clients. So one client is Zillow, the other client is Remax, and then there's another client, KWR, which is not shown here, but that also sends data. And in this case, Remax switches from app version 1.0.0 to app version 2.0.0. So this view, the issues view, is probably the main entry point to our platform. And what you see here is model regressions. So the first thing you see is that, for example, all data coming from one client seems to have a higher mean absolute error than what we've seen during training. So if you notice this, you can simply filter all the rest of the issues only for this client. And what we see here, so these are the score checks. So based on the mean absolute error, here we have data integrity checks. And what we can see here is that multiple features have a higher percentage of invalid data than what we have seen during training. So first of all, we have the actuals coming in here, and already the actuals show that 73% of incoming actuals are invalid, which in this case probably means that they're outside of range, outside of the training range that we've seen, outside of the range that we've seen during training. So either under or above the min and the maximum of this feature. And we also see this the same for other features. Now, if you scroll down further, we also get data drift checks and alerts. And again, here, if we look at the actual, we could see that there's a drift of 77%. And if you look at the distributions, so the gray line here is the distribution seen during training, and the blue line is the distribution seen in production. And what we can see here is that clearly they have shifted. And what this means is that this client is sending houses in a higher pricing range than the ones we've seen during training, and of course our predictions are way off for those. And you can also see this with other features. For example, the living area has a drift of 58%. The bathrooms drifted 56%. There's more fireplaces and so on. So there were other issues with our deployment too. So let's check these out. So one here is this client Remax, and for example, I know that this client Remax has recently updated its app version and is now sending data from a different app. And we can see here that basically all incoming data is coming from this slice, which we will copy again and filter on. And here, well, if you scroll down to the integrity checks, we already immediately see that there's 2 features that are invalid 100% of the time. So this overall quality and this round living area recently started to become invalid. And this can be seen if you remove, for example, this part, filter again, and we do not want to see sub-slices. We see that before everything was fine with Remax, and then something changed and now everything is invalid. And this is explained well, by this new app version. Now again, if we scroll down to the data drift checks, here we see the same features with a drift of 100%, and here we see indeed they all have the same value, which is out of bounds too. So this means all of these input features are invalid. Now next to this, which is probably your main entry point, we also have the dashboards, which are interactive. So I see I already have a filter applied, but if we do not apply this filter, we see these dashboards updating. So we can filter these dashboards for any slice we want. Now what's even more useful is that we can compare slices to each other. So for example, if we compare indeed, well, client KWR against client Zillow, and take the last month. Same here, we see all these dashboards updating, and what we can already see is that, well, again, this client Zillow seems to have a much more errors, upper bound errors than the other client. We also see this error distribution is way off, just like we've seen on the other view. And for example, we have scatter plots that plot these absolute errors for the traces specifically that are clickable. So if you click on this one, you get the trace, the whole execution for this prediction. We see all the tags attached to it. Most of them are related to the model profile, but for example, you could have a tag prediction time. And here you see the position of this data point in the model profile. So if you scroll further down, we also get the whole trace of this prediction and all the raw data, which we've defined some visualization on. But what's very useful is that we can copy, we can easily fetch this raw data for further debugging in a notebook by simply copying some command and executing it in Python code. Now, of course, these dashboards, you can easily add whatever you want. So for example, you could plot another tag distribution for these two slices, like the ground living area. And we can add it to the dashboard. And here too, we see, well, clearly there's a big shift, a big drift between two slices we're inspecting. So a last view that's probably pretty useful is the traces view. So this basically shows all the predictions that your model has made. Again, this is filterable like the dashboards, and you can also indicate which tags you want to see. For example, I want to see the client, let's say app, and then whatever tags there are, and then, well, everything becomes easily filterable. Again, this is also clickable, which means you can inspect the trace, inspect it in the data profile if you want it, and use this for debugging. So this is a short overview of the Raymond platform. If you want to find out more, please contact us at hello@raymond.ai or visit our website. We will be very pleased to talk to you. Thank you.